Thank you, everybody, for being here. It's wonderful to be up here taking part in this wonderful tradition of Conservancy First Tuesdays. I remember when I first moved to the Valley, First Tuesday talks were an important way for me to learn about this place, and so it's really an honor to be up here tonight now sharing some of what I know. So as Bridger said, I'm a wildlife biologist, and I'm lucky enough to have been working here in the Met How for a little over a decade now. I've worked on various projects here, from the Met How Beaver Project. I've worked with a couple of the local wolf packs, and for the Black Pine Basin Lynx study of the early 2010s. And over this time of learning this landscape and its wildlife, I've developed with it what, to me, is really one of my most important relationships. I care really deeply about this place and its wildlife, and so about 2 years ago, myself and two of my wonderful colleagues and friends started Home Range Wildlife Research. Anna Makowitz and Becca Wendells are my co-founders, and I feel so fortunate to have started this nonprofit with them. So Home Range's mission is, I've got to juggle two different clickers, so. Home Range's mission is really built around forwarding wildlife conservation, when we're conducting high quality research, we're educating aspiring biologists, and we're engaging with local communities. And so tonight I'm going to be talking about our research pillar, and specifically our flagship project, which is our Lynx and Wildfire in the North Cascades project. So one of the really special things about the North Cascades is that we have one of only 6 distinct populations that are in the lower 48, and they're shown up here in red. The core of lynx habitat and their population is really up in Canada and Alaska. So Washington's is a small population, but it's an important part of our ecosystem, and it's important to the robustness of this overall lynx population of the lower 48. And so zooming in onto Washington's lynx habitat, which is shown here in the gray, this is really it, and we're right in the middle of it. So the North Cascades is one of the few areas in the lower 48 where those deep snows and boreal forests of Canada and Alaska snake south before they start transitioning into more southerly environments. And deep snow is what lynx are really adapted to. It's part of what makes them such a unique and different wildcat in North America. So the most obvious of their deep snow adaptations are their giant feet that are relative to their size and their weight. These feet act as snowshoes and allow them to efficiently move around and hunt in the snowy winters by basically just sort of floating on top of the snow. Whereas an animal such as a bobcat, which is about the same weight as a lynx, they have such small feet in comparison to their size that they're just punching right through the snow. And so that makes it really hard for them to make a living in wintry, snowy environments. So lynx, with their uniquely giant, almost ridiculous, muppety feet, have really carved out a niche for themselves in deep snow environments where they have the competitive advantage. And importantly, these large feet allow lynx to chase and catch their primary prey, snowshoe hares. Snowshoe hares make up almost the entirety of their diet. So lynx are really tightly tied to and reliant on snowshoe hares to survive. And in turn, snowshoe hares require thick stands of boreal forest, because these habitats provide lots of branches close to the forest floor, which offer snowshoe hares protection and cover from predators, but also the evergreen needles and branch tips that snowshoe hares eat. And so because snowshoe hares live in that thick boreal forest, lynx live in thick boreal forest. So to sum up, lynx need deep snow environments with a thick boreal forest where they have the advantage with their giant feet over other predators to hunt and eat snowshoe hares. Our backyard has some of that habitat, and so we have lynx, but we don't have many. In fact, so lynx are listed as federally threatened in the contiguous US, and then in about 2016, the Washington population was listed by the state as endangered. Recent population size estimates are only around 50-ish individuals in Washington. So this leaves Washington lynx in a precarious place, at risk of local extinction. And so to understand one of the main reasons why Washington lynx are in such a precarious place, I'm going to bring another important player onto this deep snow, thick boreal forest, snowshoe hare scene that's so important to lynx, and that is increasing wildfires. Now, understanding wildfires, their role in ecosystems, and their relationship with lynx is much more complicated than just fire is good or fire is bad. And so to explain this, I'm going to give a brief history of the North Cascades boreal forest fire regime. And this history is loosely categorized into 3 wildfire eras: the historic era, the fire suppression era, and the modern megafire era. So starting with the historic fire regime, we've always had a lively regime in our high elevation forests of the North Cascades. So this is a photo that one of our local fire researchers, Paul Hesburg, has that paints a picture of what the historic fire regime once burned like and what its role on the landscape was. So we're looking at a panoramic view taken on Bethel Ridge in 1936. And what's important here to key in on is the diversity of forest ages, forest heights, thicknesses, and non-forest areas that were present on this landscape. The patchwork of different burned and regrowing and mature forests were created by those frequent small fires. I think of it as sort of a pitter-patter of fires that really textured the landscape. So for wildlife, this meant that there was this rich mosaic of forest types and non-forest areas constantly shifting over time as fires burned here and fires burned there and forest patches grew back. And so while habitat patches might have been ephemeral and dynamic, there was basically always some of each forest type available on the landscape so that each creature with its particular habitat needs was supported. And this patchwork of different forest habitats is the landscape that lynx historically lived on. And so presumably, even though fires were regularly creating areas of non or very open forest, there was enough of that thick boreal forest structure on the landscape that snowshoe hares, and thus lynx, were supported. And so in addition to creating this rich mosaic of habitat for wildlife, all those small fires worked to dot the landscape with natural fuels breaks, areas of ground that had recently burned and so slowed and limited subsequent fires spread and heat. And as Paul Hesburg has pointed out, these small fires created a negative feedback loop, wherein recent fires limited future fires. So this fire regime was self-limiting. Now, this constant pitter-patter of small fires was not at the exclusion of big fires. Some years, climate conditions were such that a big fire would get rolling and affect a large swath of the landscape. But again, all those previous small fires had created this varied fuel bed so that even when a large fire burned, it did so with less heat and with more what's called pyrodiversity, meaning that some areas just lightly burned. Some patches were skipped entirely, and some patches were torched by high severity fire behavior, which is when the fire is burning hot enough to kill most or all of the trees in that patch. So in this way, the landscape was highly heterogeneous, not only among different age burn scars, but within a single large burn perimeter. So to distill this down for the context of Lynx, we think the historic fire regime did two main things. It created this patchwork of different forest habitats that provided enough of that thick forest structure that hares and lynx need, and it safeguarded against catastrophic lynx habitat loss to really big hot fires burning too much forest over just a short time period. These are a couple set of lynx tracks going through a regenerating burn. So the historic fire regime began to change 150 years ago when human actions began limiting wildfires. And in an effort to save valuable timber, around here we started getting really good at fire suppression in the 1940s. Hundreds of fire starts were put out in the Methow watershed, snuffing out that natural pitter-patter of fires. And so by excluding fire from the landscape, these forests were allowed to grow and fill in, leveling up and homogenizing. So gone was that patchwork of different forest and non-forest habitats, and gone was that negative feedback loop as fuels accumulated and those natural fire breaks filled in. So the end result, a continuous fuel bed, really primed to spread fire and build up to a more uniformly hot and severe fire. So here again is that photo on the top from Bethel Ridge, taken in 1936, showing that rich patchwork of the historic fire era, versus on the bottom, a modern photo taken from the same spot showing how much the forest filled in during that suppression era. So these photos are pretty striking. The suppression era ended for us here in the early 2000s. At this point, we had the perfect storm. We had the loaded and uninterrupted fuel beds created by the suppression era, and we're getting hotter, drier, and windier summers under climate change. And so these conditions mean that fires are burning bigger, they're burning hotter, and they're burning more frequently, and are often beyond our firefighting capabilities. So the days of being able to rely on fire suppression are over. These are mega fires, or fires that are burning over 100,000 acres. This is not the pitter-patter and occasional large fire of the historic era. This is more of a deluge. Further, these mega fires are burning over more uninterrupted, thick fuel beds. And so they're burning with less pyrodiversity. Instead, they're burning at more of a even high severity with less area of light burning or skipping. And so fires that burn evenly regrow more evenly and into young forests with a low diversity in their fuel beds, which sets that burn scar up to burn again in a similarly unfettered and high severity way. So we've gone from this historic fire regime wherein the frequent small fires were controlling future fires to our mega fire era wherein large high severity fires beget large, high-severity fires. So what does this mean for lynx? This is our Washington critical lynx habitat again in the gray, and shown in yellow are the couple of fires that burned between the 1970s and 1999 at the tail end of the suppression era. So with the exception of these few, what at this point look pretty quaint fires, we've got lots of mature forest left. And lynx did well on this fire suppression landscape, since mature forests can be that thick forest habitat that hares and lynx need. This is our current megafire landscape. Again, lynx habitat in the dark gray. The orange shapes are fires that burned between about the year 2000 and now. So the suppression era landscape has literally backfired on us in combination with climate change. And the era of megafires presents a big problem for lynx, since recent high severity burn forests are, well, forestless. In the years after a hot fire kills most or all of the trees in a forest patch, that patch can't support hares and lynx. And by years in recent, I'm talking like 15, 20 or more years. So our landscape is now skewing heavily towards recent high severity burn areas. This is one of the biggest reasons why in 2016 lynx were uplisted to state endangered. Because the worry is that if enough area burns in a short time frame, lynx won't have that thick boreal forest. There won't be enough left in the North Cascades to sustain our population. So the trajectory that we're headed on with megafires is helping push lynx towards extinction in Washington. The threat of increasing wildfires to lynx in Washington is daunting. But recent work in the wildfire ecology field is showing us that we do have an option for reining these fires in. By using forest treatments to reinstate the historic patchwork, aka that negative feedback loop, we can bring fire resilience back to this landscape, even under the dramatic climate conditions of our times. So by using prescribed fire, some mechanical thinning, we can establish those natural fire breaks, sort of like speed bumps, to slow future fires down. And I'm not just talking about forest treatments in the areas that haven't burned yet, because older forests are not the only kind of forest that can offer that thick cover that hares and lynx need. Young forest stands can come up super thick and provide that kind of forest cover too for hares and lynx. So these young forests just need to get tall enough that even with 4 or 5 feet of snow on the ground, there's plenty of tree cover poking up to provide cover for the hares and lynx. So this is a picture of Anna in a young forest stand, and you can see that the snow is just littered with snowshoe hare tracks. So this, on the one hand, is good news for lynx, since we've got a lot of burned area starting to regrow. However, just about the time that these regrowing forests are getting tall and thick enough to be good lynx habitat, they're also aging into being great fire habitat at risk of reburning. And remember that large, high-severity fires beget large, high-severity fires. So lynx in their habitat, whether it's mature forest or young forest, just can't seem to catch a break on this megafire regime. So if we're to also limit the loss of young forest habitats on our landscape, we need to reinstate that patchwork, that negative feedback loop, back into these areas as well. And so looking back at this map, we can see the importance of saving young forest, that regenerating young forest habitat from reburning, because young forests are a lot of what's up and coming on our landscape at this point. So we've got some hope here of reining in megafires with forest treatments. However, there is a catch. Reducing fuels on the landscape would in many cases mean reducing the amount of that thick forest cover that lynx need. So this might sound like we're left between a rock and a hard place. But if we can understand how lynx use habitat on a landscape heavily impacted by megafires, we might be able to take some lynx habitat in a smart way and in such a way as to minimize the immediate effects to lynx while we're ensuring that we're managing to reduce the risk of megafires and thus catastrophic habitat loss for the longevity of our lynx population. And so in this way, we could take some lynx habitat to save lynx habitat. The only problem is that we know very little about how lynx are using this habitat on our megafire transformed landscapes. And so managers don't have the information they need to treat this landscape in such a way that it meets both objectives of lynx habitat conservation and fire resilience. So getting that information so that managers can carefully take some habitat to save habitat is exactly our goal with the Home Range Lynx and Wildfire project. So we're working to learn what burns habitats lynx use, what arrangements, what amounts of these habitats lynx use, and just as importantly, what regenerating habitats lynx still aren't getting much use from. So in other words, these are the answers that we need if we're to bump Washington lynx off their current trajectory towards extinction from Washington and conserve their place as one of the most special and unique members of our North Cascades ecosystem. Enough doom and gloom though. We'll move on to the fun part, which is how do we go about getting these answers? Well, the upshot of having had so many megafires over the past 20 or so years is that we have an amazing study area. And right now, some of these earlier megafires that burned in lynx habitat are starting to regrow enough that we're seeing, again, lynx are making use of these areas. So specifically, the 2006 tripod burn, which is this big yellow one, which burned most of what was considered the best lynx habitat in Washington. It's now almost 18 years old, and we're starting to see significant lynx use in this area again. So in the tripod burn scar, we've got an incredible opportunity to learn what habitats lynx use on a megafire landscape. And importantly, we've got some lynx out there using the tripod burn. These are the individuals that we can learn so much from if we can just capture data from their daily movements and behaviors as they're living their lives out there on this megafire landscape. And so that's what we're doing. We just wrapped up year one of our field work, collecting our first rounds of data in a few different ways, with the largest amount of our effort and data coming from what's really one of the jackpots of data collection techniques for rare carnivores, which is GPS collaring. So these are collars that are fitted to individual animals that collect highly accurate GPS locations as these animals are just out moving around in their habitat. So this is how we can learn in detail how lynx are living on a megafire landscape. Of course, it's easier said than done. It takes a lot of hard work and persistence and grit to get to this moment of having captured a rare carnivore fit it with a collar, and releasing it again. One of the first challenges we confront is simply accessing our high elevation study area in the winter. So we use snowmobiles, and most days we feel really, really lucky that this is our commute. But snowmobiling is not always easy, and we do spend some time getting stuck, and then digging our sleds out, tipping our sleds over, flipping them back upright, before finally getting unstuck. I truly am sorry, Anna, that I sprayed you with all that snow, but it was really funny. Okay, so simply accessing the study area can be really challenging. Then there's the actual capturing of a lynx. Our study is 175,000 acres, and there are maybe 6, 8 lynx. We're not really sure how many are in the study area, but the point is this is a rare, endangered species, and they're few and far between, which makes capturing them really difficult. So the first step to trapping a lynx is finding a spot on that 175,000 acres that they use somewhat regularly. So for example, here's a spot where a lynx was hunting. You can see its tracks where it was pacing back and forth on the shoulder of the road, peeking over looking for snowshoe hares. So potentially a really great spot to capture a lynx. So once we're in a spot that we know is frequented by lynx, it's time to set our traps. And our traps are made of a PVC pipe frame and then wrapped with chicken wire, and were generously constructed by volunteers at a trap building party we threw last fall. And we have a trap here tonight that we'll demonstrate with after the talk. But basically, there's a tripwire in the back of the trap that when bumped, it will release the door, trapping the cat.
Go for the thing.
Or in this case, me.
Yeah.
So to set the trap for the lynx, we place it in the snow, sort of nestle it in, and then we cover the sides and the top with boughs. And that gives it sort of that intrigue of a little nooky, cranny spot to investigate, a bit like when a domestic cat gets excited about a paper bag or a cardboard box on the floor. So we're playing on that behavior a bit. Then we lay our attractants. We use roadkill deer, and so we just hang a chunk of that in the back of the trap. So this is Clara butchering up a deer, and then in its final form, the bait hanging there in the back of the trap. We also use strong-smelling scent lures that are designed to appeal to a cat's curiosity. And those scents would be something like skunk essence or catnip. We use catnip. Some of them are a paste of aged, ground up, who knows even what kind of carcasses. And then some of them appeal to their territory or breeding instincts. And so we've got squeeze bottles of lynx pee and lynx gland paste. So you get to where you don't notice the smell so much, but when you go home, somebody points out that actually you do smell like skunk or cat pee or whatever. Finally, and very importantly, cats are visual hunters, and as anybody with a pet cat knows, that twitching a feather or something shiny can really get a cat going. So we play on this behavior too, and like to hang a shiny piece of bird tape or feathers outside the trap to maybe catch the eye of a lynx. And then we also hang a little feather in the back of the trap to sort of twitch in the breeze. Even after throwing all of this at them, more often than not, they still decide not to go in. So every single day during our winter field season, we are grinding out there. We're checking our traps, we're setting more traps, and we are pulling out our hair when we see the tracks from the night before of a lynx walking right past one of our traps without going in. But all that hard work pays off the day you pull up to a trap and there one is, this creature that so few people get to see in the wild. This is an individual animal that is going to help us learn tons of what we need to know about how to save their habitat. Their GPS collars are going to collect thousands of data points telling us exactly what burned habitats they're using from half hour to half hour. So getting a GPS collar onto a lynx is a major coup, and it took the hard work of this team here. We've got Anna, my partner in crime, and our fantastic field bios, Christine Phelan and Clara Hoffman. And as many of you may recognize, our local lynx legends, John Rohr and Scott Ficken, helping us with these handlings. I also have to give a shout out to Kelly Rohr for loaning us her umbrellas for snowy capture days so that we could shelter our lynx handling station, and for the time she managed to whip up a batch of brownies to send in time to send the entire pan into the field for our post-capture field celebration. So sometimes once a lynx has been captured for the first time, something happens that's called getting trap happy, where an animal realizes that it's actually not that bad to go into a trap. You get a free meal, and then the next morning, biologist comes and lets you out. You might even have time to hit a second trap that day. So that's what happened with our first lynx that we caught last winter, M001. He decided it was well worth getting trapped to get a free meal. And so this footage is of the 11th time that we caught him. And notice that after he grabs the bait in the back of the trap, he doesn't let go of it even at the startling sound of the door closing. Yeah, he just keeps working on that bait. So it got to where we were pulling the traps out of his territory as fast as we could and moving them elsewhere, because the amount of time he was spending in and around our traps was ruining his data, biasing it towards our traps. Plus, he was just bunging up the works and eating all of our bait. But then there was a lynx just to the south of our little trap bandit, M001. We could never get him to go into a trap. He barely even seemed to sniff at the bait. He did not just go in that trap. He just brushed by on the other side. So we tried all sorts of trap sets and baits. We found a dead squirrel and we hung it in the back of the trap in this tantalizing pose, but nothing worked. I've got some ideas for this winter, though. So more often than not, lynx are not like M001. Their attitude towards the trap is much more like this guy's. So our first year, this past winter, we did manage to catch 4 lynx, 3 of which were large enough to put collars on. We caught 2 males, and we caught this female. Unfortunately, this female died only about a month after we caught her, hit, we think, by a snowmobile. But those 2 collared males are out there as we speak, collecting bait. Not bait, data. They wish. So here's a snippet of the data, which at this scale might not look like much, but each of those little blue dots, once analyzed with statistical models, will tell us so much. They'll tell us what thickness of regenerating stands that lynx prefer, what habitat patch shapes and sizes lynx select, or what exact height these trees need to have grown to be usable to lynx. This is all really important detail for understanding what burned habitats are useful to lynx and should therefore be fostered and conserved, and what kind of impact to lynx different forest treatments plans might have. And so in addition to this GPS collar data, this past summer, as those lynx were out there being lynx and collecting data along the way, we were gathering complementary data. So we set trail cameras to increase our lynx detections. So you can see one of our collared lynx here on the left, and then a couple fun incidental photos we got, a badger, wolf, and of course a moose. And we went to spots where we knew lynx had been to collect fuels data that will tell us how flammable the habitats that lynx use are. So our fantastic field crew worked all summer to estimate fuels, measuring everything from the abundance of the tiniest twigs on a site to the length and width of every single log at a site. So this is detailed data. And in this first summer alone, we measured over 5,000 logs. So this is going to be really, really cool information because it's going to allow us to model what good lynx habitats are overlaid with what's good fire habitat. This intersection is one place that we think our results can be really directly applicable to conservation by illuminating where on our landscape we need to take action to reduce fire danger balanced with preserving important lynx habitats. So for example, will a certain treatment plan have little negative impact to the current lynx habitat, but only a bit of protection against future hot fires, and therefore not much safeguarding for the longevity of our lynx habitat? Or would it have a high negative impact to our current lynx habitat, but a robust reinstallation of fire resilience? Or hopefully, a treatment plan will hit that sweet spot of causing minimal impact to our current lynx habitat conditions while also protecting against future big hot fires, thus conserving this lynx habitat over time. So to answer these lynx and fire questions really well and in a scientifically robust way is going to take us some time. So we'll be out there for the next 2 years at a minimum, working to deploy collars, tracking lynx, and collecting that habitat and fuels data. This is how we're going to strive to understand how lynx are using this newly transformed megafire landscape. This is the information that we need to help lynx conservation. Because megafires are not going to stop, and without intentional forest treatments, they're going to keep increasing. For example, this summer, of course, the Crater Creek fire reached megafire status in only a matter of days. And while most of this fire was in Canada, lynx, of course, don't know borders. And this fire was in lynx habitat. So this is why this work is so serious to us. As wildlife biologists, our piece to contribute to lynx conservation is research so that managers can make informed and effective science-based decisions. But one of the other big pieces of successful conservation is having the understanding and the support of our surrounding communities. So I want to thank you all for coming tonight to learn about lynx and wildfire, since protecting Washington's lynx is going to take effort from everyone in this community. And so with that, I'd like to thank our funders, the Paul G. Allen Family Foundation, Panthera, and the U.S. Fish and Wildlife Service. And so important to the financial future of this project are individual donors, and the Conservancy for having us tonight. Go ahead. Thank you. Really quickly, this project is also the effort of a large group of fantastic minds, and so I'd like to thank our advisory team, our project team, and our community scientists.